This chapter has focused on teaching you aromaticity in the ring and talking about how aromatic rings have extra stability in them. It's also talked about how they don't react normally because of that extra stability. And so if we wanted to get rid of the aromaticity of a ring, it would be difficult, and we've come up with a reaction to help us do this. This reaction is called the Birch Reduction. The Birch reagents are sodium, methanol, and ammonia. And what this reaction allows us to do is it allows us to remove the aromaticity of the ring, and it takes away one of the pi bonds and leaves two pi bonds behind after the reaction is completed. The one thing you want to point out, or I want to point out, is that the diene is isolated. So this is an isolated diene as a product. So it doesn't form a conjugated diene. It moves the double bonds into a position where they are now isolated and completely removes that stability that was formed from the aromatic ring and any stability that would be formed from a conjugated system. So this is the product that you would get just for a regular benzene molecule. You'd end up with this diene that is present. Now below, I want to look at a derivative of a benzene, or if there was a substituent attached to benzene. In this case, we're looking at toluene, and toluene specifically has a hydrocarbon chain, or R group, attached to the benzene ring. Okay, and we should be familiar with these hydrocarbon chains being electron donating. We know that a tertiary carbocation is more stable because the carbons will donate some electron density that are attached to the carbocation. And so that same principle is happening in this situation. The R group is donating electron density to the ring. Okay, so if the R group is donating electron density to the ring, you are going to end up with a specific conformation of the diene. So we have our methyl group attached to the ring in that location, and the diene, or the double bonds, are going to be in this position. Okay, again, still isolated, but the one of the double bonds, the carbon that they're attached to, is the same carbon that has the R group, or the electron donating group. Now let's look at what would happen with an electron withdrawing group. Okay, so this is the benzene, or this is a benzophenone. The benzene has a ketone attached to it, and so the ketone is electron withdrawing. Okay, and we're still doing the Birch reduction, and so you're still going to end up with that diene in the ring, but now it's not going to be it's not going to have the double bond attached to the carbon that has the substituent on it. So we're going to see that the double bonds now don't want to be attached to that area where the electron withdrawing group is sitting, and so this is going to be the conformation you will find.